Automation 101, how to translate your workflow from Blender into the CLI. This video explains how to move from working on a single asset at a time in Blender to setting up a batch processing pipeline to work on multiple assets at a time by leveraging the power of the CLI. First step is to open Blender and invoke the Rapid Pipeline add-on. Let's import a CAD file to test the processing pipeline. Expand the import options. Then set the tessellation to extra fine. The extra detail will give the decimator plenty of room to automate the best surface detail for each asset. The CAD sewing tolerance should be fine at the default value. Remove T-junctions will help resolve any cracks that may appear between the CAD patches once they're tessellated. We'll convert the axis into Y-up, a common need when moving from CAD software into 3D rendering software. Fixed winding order is great to flip any inverted faces, which might be caused by mirroring or using negative scale in the CAD software. Then we'll import the file. Rapid Pipeline shows what it's doing each step of the way in the process log. The model has finished importing. The first step is to open the viewport overlays and enable statistics. This will show us how many nodes there are in the scene and the overall triangle count. We'll press A on the keyboard to select all the nodes. The asset has 646 nodes and 234,000 triangles. Let's choose an action button as a starting point for our batch processing settings. Decimate and Bake Atlas is a good place to begin. Bake Inclusion Map is a good choice for real-time rendering since it improves realism. Then we'll set the face target to a high number. This is an upper bound, the maximum number of triangles to allow for any asset. Because we are setting up a batch process, we'll want to leverage a quality-based decimation metric. For this, we'll use the deviation percentage, which allows the decimator to judge each asset independently and decimate according to the local curvature. We'll set a fairly high value of 0.05, which allows a deviation of 5%. Feel free to choose a different number here if you need to. We'll set the Atlas mode to single, which will create a single shared bake for all the output materials to keep it efficient. Merging we will set to by material, which will merge all the nodes that share the same material. This helps optimize the rendering performance by reducing the number of separate mesh nodes. Then press the Run button to see our output. Rapid Pipeline flattens the nodes, decimates by deviation, unwraps a new shared UV atlas, then bakes the textures. Here it's creating a shared ambient occlusion map, and it's also baking a normal map which helps preserve all the high-res detail from the original tessellation. Then it removes any unused flat color textures and pulls the result back into Blender. Looks great. Now let's see how to turn this into a CLI workflow. Go to the Settings button up top and enable Expert mode. This will copy all the settings from the action we chose earlier, then expose all the advanced 3D processing settings. We can see in the scene graph flattening that it's set to by material. This was one of the options in the action for Decimate and Bake Atlas. 3D Edit and Mesh Culling were not part of the action, so they're blank. Optimize and Bake has the decimation settings we set earlier. 10 million triangles, 5% deviation, plus all the other baking settings. Modifier was also included in the action, but we left it at the defaults, so it's basically disabled here. Let's add some more settings to our batch process workflow by opening the Mesh Culling tab. Most CAD assets have hidden interior parts, which bloat the file size and usually are not needed for rendering. Occlusion culling automatically removes all these unseen parts. Let's increase the lump threshold, which will allow it to be a bit more aggressive in removing those interior parts. Now let's export all our settings into a preset config file. This is a text file in JSON format that the CLI can use to process all your assets. Let's name this with a sensible name so we can call it from the command line later. Then save it. In the folder, we can see the original CAD asset and our new JSON preset file. Opening the JSON in a text editor, we can see all the settings that we edited inside Blender. Scene graph flattening, mesh culling, optimization, and the empty modifier. Then let's find the settings for import and for export. On the website, open the reference documentation. Find the CLI tutorials, and in the introduction, scroll down. Here you can learn about how to run the CLI. how to access the CLI help, and various ways to use the CLI. Here's how to import and export. This explains how you can use multiple JSON files to precisely control each stage of the batching workflow. We provide handy pre-configured JSON files for the import and export steps, which you can download here. Let's save the import config into our folder. Let's also save the export config. Open the import config to see how it's set up. This contains the most commonly used settings for importing CAD files. Let's also look at the export settings. This has 4 file outputs, one for GLB, another for USD format, a third going out to USDZ, and finally an FBX output. Feel free to edit these as needed. Let's open the Windows PowerShell and start using the CLI. First off, type rpdx and press enter. This shows us it's working and shows us some version information. Let's look at the online help by pressing rpdx-h. Then we can start writing our actual processing command. rpdx-i is for import. Then we'll hold the Shift key and press the Tab key to cycle through the files in our folder. There's our CAD file. Then we'll type --read_config and Shift Tab to load the import settings. We'll do the same thing to load the processing config that we saved out of Blender. Then we'll add one more, the export settings. Finally, we'll end with -r, which tells the CLI to go ahead and process the whole command, and press enter to get it all started. The CLI will print out a running list of all it's doing: loading, sewing, repairing, decimating. It figures out what's invisible inside the model, then generates the UV atlas and starts baking the textures. It's preserving all the original detail from the tessellated input model, baking this into a detailed normal map, and saving it into a shared texture across all the meshes. Now it's generating the output files. And it's done. Let's examine the results by opening the GLTF sample viewer. The CLI has generated an output folder, which contains all 4 output files which were specified in the export config file. We can drag and drop the GLB file into the sample viewer. If you open Advanced Controls, you can see that there are 6 mesh nodes and 90,000 triangles. Of course, this number will vary for each of your files based on the deviation percentage and the particular details in each source file. If we go to the debug channels, we can look at the occlusion texture, which shows we have a high-quality noise-free bake, preserving all the detail from the original asset, but at a fraction of the triangle count. We can also see how the normal map has preserved high-resolution shading detail from the original surfaces. GLTF Report is another handy online tool, which shows the 6 meshes share 2 atlas textures for the normal map and the occlusion map. Rapid Pipeline gives you the tools you need to set up your workflows, allowing you to work on each file individually and move that process over to the CLI for further automation. Try it for free or chat with our human team right on the website.